So in this question, we are asked to find the value of x, and there is a constraint that x is any non-negative value. So the question is 4 power x plus 10 power x equals 25 power x. So first of all, we will divide each term by 4 power x. So 4 power x. Now we see that in the first term, 4 power x divided by 4 power x gets cancelled, and we will be left with 1 plus 10 power x divided by 4 power x can be written as 10 divided by 4 whole power x. Why? Because we know that a power m divided by b power m is equal to a upon b whole power m. So likewise, equal to, this will be 25 divided by 4 whole power x. Now we see that this numerator and denominator can further be simplified. So let us divide them by 2. So this is 2 and here it will be 5. So this will give us 1 plus 5 upon 2 whole power x equals 25 can be written as 5 square, 4 as 2 square whole power x. So this will be 1 plus 5 upon 2 whole power x equal to 5 upon 2 whole square to the power of x. Further, we can write it as 1 plus 5 upon 2 whole power x equals 5 upon 2 whole power x whole power 2. So we can exchange 2 with x. Why? Because again we have another property that a power m whole power n is equal to a power m times n, which is equal to a power n whole power m. So we have used this property here. Now let us assume that 5 upon 2 whole power x is equal to t. Let us substitute this value of t in the obtained equation here. So the equation will be 1 plus t is equal to t square. This will give us a quadratic equation, t square minus t minus 1 is equal to 0. We will use the quadratic formula to find the value of t. So let me recall quadratic formula. It says that if you have a quadratic equation, ax square plus bx plus c is equal to 0, where a not equal to 0, then x is given by negative b plus minus square root of d divided by 2 times a, where d is the discriminant, which is equal to b square minus 4ac. So here a will be 1, b will be negative 1 and c will be also negative 1. So discriminant d will be b square, that is minus 1 square, minus 4 times a is 1 times c is negative 1. So this will be 1 plus 4 is equal to 5. So t will be equal to negative of b, that is minus 1, plus minus square root of d, that is 5, divided by 2 times a, that is 1. So this will be 1 plus minus root 5 divided by 2. So from here we will get two values of t, 1 plus root 5 divided by 2 and 1 minus root 5 divided by 2. Since root 5 is greater than 1, so 1 minus root 5 divided by 2 will give us a negative value of t. And t is linked to x via this relation. So if we substitute negative value of t, this may result in x being negative. So we will discard this. Now we have t is equal to 1 plus root 5 divided by 2. We can substitute the value of t, which we assumed. So 5 by 2 whole power x is equal to 1 plus root 5 divided by 2. Now we have to solve this equation and find the value of x. For that, let me erase the whiteboard. So we can start solving here. First of all, we will take natural log of both sides. So ln 5 by 2 whole power x equals ln 1 plus root 5 divided by 2. Now we know the property of logarithm, that log m power n is equal to n times log m. Base could be anything. Let us take b here. So we will apply this property here and we will get x times ln 5 upon 2 is equal to ln 1 plus root 5 whole divided by 2. So let us rearrange this. So x will be equal to, in numerator, ln of 1 plus root 5 divided by 2 whole divided by ln 5 divided by 2. Now we can express this as ln 1 plus root 5 minus ln 2 divided by ln 5 minus ln 2. Why? Because we have another property of logarithm, that log base any number m upon n is equal to log m minus log n. We will have the same base. So here log 1 plus root 5 divided by 2 will be log 1 plus root 5 minus log 2, and same with the denominator also. So using calculator we can find the value of ln 1 plus root 5, ln 2 and ln 5. ln 1 plus root 5 will be 1.174, ln 2 will be 0.693 and ln 5 will be 1.61. So let us substitute these values. So ln 1 plus root 5 1.174 minus 0.693 divided by 1.61 minus 0.693. On solving this, we will get 0.5245. So we have found the value of x as 0.5245. If you want to get more such videos, do subscribe to my channel. See you in the next video.